All right, we are going to work on understanding end behavior of polynomial functions. So how do the sign of the leading coefficient and the degree of a polynomial affect the end behavior of the graph of a polynomial function? So end behavior, what the end behavior of a graph is, it's the behavior of the graph as x approaches positive infinity. I'm just going to put a plus for positive infinity or negative infinity. Maybe we should write that in. That looks a little weird in this sentence. Positive and negative infinity. Okay, so let's look at some examples and make sense of what the idea of end behavior is. So if you have an odd degree and you're positive and you have a positive leading coefficient. So for example, if your equation is f of x equals an odd degree and a positive leading coefficient, so it could be 2x to the first power. Or it could be f of x equals 5x to the third power. The degree is odd. This is raised to the first power. This is raised to the third. And your leading coefficient is positive. It's a positive 2, a positive 5. So the end behavior as x approaches positive infinity. So we're getting into some notation. Make a little note. This arrow is as x approaches positive infinity. What that means on a graph is just as you head out this way on a graph. As your x's get bigger, as x approaches positive infinity, what happens to your y's? The y values approach positive infinity. So as x approaches positive infinity, that's the right side. For the y's to approach positive infinity, that means your graph is going up in some way over on that end of your graph. What about the left side of the graph? As x approaches negative infinity, so that means as we're heading to the left toward negative infinity, is our graph going to go up or is our graph going to go down? Y approaches a negative infinity. So on that side, our function will be going down. And if you type both of these into your graphing calculators, you'll see, yeah, y equals 2x. It's going up on the right, down on the left. Y equals fx to the third power. It's going to do some different things in the middle, but the end behavior, it's going up as x approaches infinity. So it's your y is approaching positive infinity, and it's going down as x approaches negative infinity. All right, so let's run through the rest of these. If your degree is even and you have a positive leading coefficient, so f of x equals 2x squared. Here is an even degree, positive leading coefficient. F of x equals 4, I'm just going to keep with the 5x to the fourth power. So our end behavior as x approaches positive infinity, that's the right side of your graph, the y's are also approaching positive infinity. So a little sketch of that. As x approaches positive infinity, your graph is going to approach positive infinity. It's going to go up on the right. As x approaches negative infinity, the y's are also going to approach that positive infinity. So on the left side, we can see it's going to go up on, the end behavior is going to go up toward positive infinity on the right and up toward positive infinity on the left. All right, what if your degree is odd but you have a negative leading coefficient? So f of x equals, let's say, negative 2x to the first power, or f of x equals negative 5x to the third. So it is an odd degree, but negative leading coefficients. So as x approaches positive infinity, the right side of the graph, what's happening to the y's? Your y's are approaching a negative infinity. So a little sketch of that tells us that our graph is going to be going down in some way on that end behavior. As x approaches negative infinity, the left side of your graph, the y's are going to approach a positive infinity. So it's going to be going up on the end. Again, different things are happening in the middle here, depending on what your function is, but I know in the end, this graph will be heading down in some way on the right and up in some way on the left. All right, last one. If you have an even degree, so let's see, f of x equals a negative leading coefficient, so negative 2x squared, even degree, negative leading coefficient, or maybe f of x equals negative 5x to the fourth. What is our end behavior? So our end behavior as x approaches positive infinity, again, that is just talking about the right side of your graph. As x approaches positive infinity, the y's will approach a negative infinity. So that means your y's are going to be going down on the right. As x approaches negative infinity, the y's will approach negative infinity. So it goes down on the right and down on the left. So there you go. That's a lot of fun stuff to digest.